My name is Matt Kondolf. I'm a professor of environmental planning and geography at the University of California, Berkeley. I'm a fluvial geomorphologist, and I study rivers and their management and their restoration. Rivers and streams carry water, sediment, and biota from the entire river watershed down to the sea or a lake. And through this process, rivers connect the landscape. They're like the arteries or the veins of the landscape. And so if some part of the river basin is sick in a way of rapid erosion or some source of contamination, that is transmitted down through the river system. But rivers also have the capacity to cleanse and to process some of these contaminants. So if the pollution is small enough, the river can often break down those contaminants in the course of carrying them downstream. Yeah, just as rivers were the center point of human settlement because of the transportation value, the rivers as are a linear feature in the landscape, and so many linear transportation corridors have been built along them. Frequently, we have highways along rivers or railroads, and these can be a huge barrier to cities reconnecting people with their rivers, because in many cases the rivers are cut off by these linear transportation features. There can be many competing priorities. A very common one is flood control versus human access or ecological value. So, for example, to improve the efficiency of the river in carrying floodwaters, it might be simplified, the geometry, or to make it more suitable for navigation, they might simplify the geometry. So it's often the case of trying to manage these different uses of the river, which may be competing in terms of how you would structure the river, how you would manage it. And in finding a suitable balance, more and more we're looking for ways in which we can take actions that achieve both. So, for example, a lot of projects that set levees back from the river, allowing the river to reoccupy its floodplain during floods, which is a way of managing floodwaters more effectively, but it also provides parkland and habitat. Rivers are carrying not only water, but also sediment. That's one of their main roles in the landscape. And that sediment is carried down. It supports beaches on the coast. It supports deltas. But when you build dams, that interrupts this continuous process of carrying sediment from the eroding mountains to the sea. And there are two main consequences of this. One is the reservoir was built to store water. They didn't really have sediment in mind, yet the sediment is inexorably accumulating in the reservoir. So over time, you lose the capacity to store water in the reservoir. And ever since the early 1970s, we have been losing more storage in our reservoirs globally. We've been losing more storage to sediment than we are gaining through construction of new dams. And the other consequence is downstream. Because the dam is trapping the sediment, the downstream river does not have its natural sediment load. And this has big consequences for the form of the river and the process of the river. The very architecture of the river itself is being lost because the sediment that makes it up is being carried downstream without being replaced. Beaches are starved of sediment and they begin to shrink and cause coastal erosion. And deltas do not get their sediment load that they need to balance subsidence and wave erosion. Depending on the size of the dam and the slope of the river and a few other factors, it is often possible to manage the sediment that flows into the dam from upstream and manage it in a way that you can make the sediment pass through the reservoir and out through the dam and continue downstream. And if you can do this, this is great, because then you can sustain the capacity of your dam over time. You're not going to have the reservoir fill up with sediment, but it will continue to function as it should. And the other benefit is downstream, you provide the river with its natural sediment load. So you're not starving the beaches, you're not starving the delta, you're maintaining that balance, that natural balance. The techniques are basically having large outlets at the base of the dam, and then during floods, you lower the reservoir so that the water flowing in continues to flow as a river out through the dam. That's called sluicing or sediment routing. The most sustainable approach to river and stream restoration is to restore river process and river connectivity. We're usually after recreating the habitat for a fish or a bird or some other species that we value. And sometimes the focus is very much on directly creating that habitat. But if we step back, we see that those habitats that these species are using, they are the result of the river processes, the fact that the river has a meander and it's eroding the outside of the meander bend, and large trees are falling in and creating complex habitats. And on the other side, you have a point bar building out. This is a sandy sandbar that builds out, and as the outside of the bank erodes, this inside sandbar is building up. And these all create these distinct habitats for plants and animals. And as long as you have those processes, you're automatically creating the habitats. And so those are really the most sustainable processes, the most sustainable restorations, the restorations that restore these processes that will then give you the habitats. Rivers have the potential to serve as the nuclei for urban renewal, for people having an opportunity to get out, get healthy exercise and fresh air, and to bring back some of the natural processes that we used to be exposed to all the time. Once the water quality is improved in rivers, you can invite kids to come down and play along the edge of the river. You can take kayaks or canoes down the river. So there's tremendous opportunity for recreation, open space, and the river is then also doing work for you in terms of if you give it a wide enough corridor, it can convey floods without getting into urban areas. And it will typically, the river and its floodplain can serve to clean up contaminants and improve water quality.